Hello, everyone, and welcome to the Energy Options for Off-Grid Homes webinar. All attendees are in listen-only mode. However, if you do have any questions along the way, you can type them in the questions chat area of the GoToWebinar panel. We could potentially cover some of those along the way, or we'll save some time at the end to address those questions. The most common question asked is if this webinar will be recorded, and the answer to that is yes. A link to the recording will be provided to all after the webinar ends. Now, while I introduce our next speaker, I'm going to throw up a poll here, and please do choose one of the following answers that best applies to you. Now, Jamie Lyons of Newport Partners has over 20 years of experience with evaluating the performance of a wide variety of building technologies. He conducts modeling analysis, monitors building systems in the field, and performs energy, economic, environmental analysis of building technologies with a specific focus on high-performance buildings. Jamie works closely with builders, designers, product manufacturers, utilities, and code officials in his work, and holds a bachelor's in mechanical engineering and a master's in environmental engineering. Now, with the poll still being up, I'd like to give the poll maybe about 10 more seconds so we can collect just a couple more responses from all attendees. Alrighty, so I think we have a count here of attendees that have answered. I will go ahead and close the poll now. And I will share those results. Jamie, are you able to see the results?
I am. Looks good.
Great. Now, without further ado, I'll pass the screen over to Jamie now.
I'm going to share my screen. Thank you, Preet. Jump over here to the slides and we'll get started. So thanks everybody for joining us today. Based on the poll results, it looks like we have a lot of people interested in off-grid home designs, not that many people who have firsthand experience as a builder with them, which makes sense. So this should be a good opportunity to learn about this segment of the market. So jumping right in, let me get that out of your way. This course is certified for continuing education credits under AIA, GBCI, NARI, and NAHB. So if you're registered to obtain those credits, you should be awarded with those after completion of the course. We have copyrighted materials. So jumping into the course description, we're going to cover the topic that you might suspect, off-grid homes. We'll talk a little bit about what that concept really means. And then we'll get into the motivations and the reasons for project designs to go this direction. Why are some residential buildings built off-grid in today's market? And then we'll jump into what does that mean in terms of the energy systems for the home? How are they different or the same from grid-connected homes? And then we'll look at the rest of the home's design in terms of the building envelope, the mechanical systems, the appliances, all through the lens of the off-grid design, and see how product and system choices all have to contribute to the off-grid design and performance of the home. And then lastly, we'll talk a little bit about homeowner behavior and their role in an off-grid home. So the learning objectives really sort of follow along with the course description. We'll talk about the concept of off-grid homes and the motivation or the implications for energy systems and technologies. We'll look at the available options for renewable energy generation, energy storage, and then the backup power generator. We'll talk a little bit more about the features of off-grid generators. And then lastly, we'll look at building design, appliance selections, mechanical system design, and how they're all important to integrate into an off-grid design. So first topic. Living off the grid. So what exactly does this mean? In simple terms, it means that we have an off-the-grid home that doesn't require a constant supply of energy from off-site sources like the electrical grid or perhaps a natural gas distribution system. It doesn't need those connections to centralized utilities in order to operate. Oftentimes, off-the-grid also extends to water and sewer, and in some cases, residents might even be very independent in terms of their food supply. But for the purpose of the course today in this module, off-the-grid is defined as no connection to the electric grid, no connection to natural gas distribution. Historically, these have been really, homes of this type have tended to be really remote locations, maybe somewhat rustic in terms of their size and their features. As we'll see in the slides ahead, that's really no longer the case for a lot of projects. So the rationale or the motivations for living off-grid, there's a few, and it's a little hard to wrap your arms around these because it's not a one-size-fits-all type of market. There's different reasons and a lot of different types of off-grid homes. But in general, remote locations are still a really prominent reason that a home might be off-grid. Homes of this type are just so remote that a utility hookup to the electric grid it's not feasible, or if it is feasible, it's extremely costly due to the location of the site. Extending the grid out to a remote site could cost thousands of thousands or over $10,000 in some cases. So that's one big motivation. Another is energy independence. For a group of homeowners, they seek to have independence from central utilities. They prefer to manage and maintain and store all the energy they need to operate and live in their home. Propane, if it is used at a house, and we'll see several examples of off-grid homes that do use propane, it's a little bit different in that it's not sourced from a central utility and needed continuously. Rather, it can be bought and stored on the off-grid site in large quantities that last months or perhaps a year or more. Going a little further, additional reasons for off-grid designs could be in some limited markets. There are now really high interconnection fees to connect to the local distribution system. So it might not be an extremely remote site, but the interconnection fee can be quite high. And here's a sort of a telling quote from a mechanical designer in California. For a few dollars more, especially compared to the cost of a new hookup or a slightly adjusted hookup from the utility, you can be off-grid pretty darn fast with every creature comfort you'd like to have. Being completely independent of the grid is a lot of appeal for many Californians. So in some markets, the economics of connecting to the grid combined with the cost of technologies that you would use in an off-grid design like PV and battery storage and a backup generator, those economics can make it pretty tempting to look at an off-grid design. So that's basically what this quote is stating. And as we just mentioned, additional reasons for off-grid designs being more feasible and more common is shown here. Lower PV prices. PV is used on many off-grid designs that have that renewable generation there at the site. And as the red line here shows, over the last 10, 15 years, the price has dropped by a factor of 2 or 3. So it's really changed the availability of PV for different projects. At the same time, battery storage is more widely available. There's more options and technologies. Prices are falling there as well. And lastly, that third component is propane off-grid generators are also available from multiple manufacturers that, again, provide more options and cost competitiveness in the market for off-grid designs. So some of the energy implications for living off-grid, we want to focus on that because they do differ from what you'd expect in a typical grid-connected house. So we've mentioned a couple times already on-site electric energy generation. Off-grid homes, they can't rely on the grid for electrical power, so they will generate their own electrical power. Typically, this is done with PV, which is a renewable energy resource. Other options might include wind or Micro-Hydropower. And we'll talk just a little bit about each of those two. The second sort of key component is storage. A home won't use electric power at the same rate that a PV system might generate it. It's just a total mismatch in terms of the generation profile versus the way a home would use the energy. So we need storage. The storage lets PV power be generated and stored in the batteries, and then energy flows from the batteries to the homes to support its electrical needs. And then this third component that we'll mention is sort of the backup safety net. It's an off-grid backup generator. PV, wind are both going to be intermittent. They're not always going to produce power. And at certain times of the year, they might not produce enough power to keep the batteries charged. So at those times, the home simply can't not have power. Instead, we use an off-grid generator to recharge the batteries so that the home has this always available continuous supply of electrical power to keep things running. So there's a good number of recent off-grid project examples out there, but they're not all recent. This is a pretty interesting subdivision, which actually dates from the early 1970s. It's a 4,000-acre off-grid community with 600 properties. So we have a lot of residential sites here in Oregon. And given that it was built decades ago, initially, PV was not as universal or cost-effective at that point, so generators were used for the most of the electrical generation. Over time, though, a lot of the homes in the community now use PV as the primary electric generation with batteries, and then there'll be an off-grid generator in the background to recharge the batteries when that's needed. And those generators tend to be propane, and then many of the homes there also use propane for what we'll call the thermal loads, the high heat loads, space heating, water heating, cooking, and clothes dryers. And because this site is so remote, the residents really are quite independent, and for that reason, they also employ a number of wildfire mitigation practices to protect their homes from the wildfire risk that could crop up in that area. So PV systems really are, one of the three key components we'll talk about a little bit. And there's been a lot going on in that industry. We saw how the price was falling, and interest and deployment of PV, in large part due to that price, is really on the rise. And this graph shows the net solar PV capacity from small scale residential systems. And it's about a 3.5 times increase in just the last 5 years in the marketplace. So real big growth in residential PV. And granted, most of that's on grid connected homes, but for off-grid designs, this can really make the economics work out much more favorably. But there's some things to keep in mind with PV. It's not like being connected to the grid, really. You have cloudy days, you have cloudy parts of the day. And then what we see here, if you look closely, those are months on the bottom, and it might look like a roller coaster. Some in the industry would call this a solar coaster. And the point is, as you might imagine, we get a lot less generation from PV systems in the wintertime as compared to the summer. And that's due primarily to just simply fewer hours of sunlight. And I think we're all experiencing that in the country now as we get into December. Less hours of daylight during the day, so less PV generation. The angle of the sun can also be lower. Some areas can have more cloud cover in the winter. So the net result is we're not always going to get the same daily or monthly output from the PV on an off-grid home. This map shows solar resources on an annual average basis. And the real high solar resource areas are in the Southwest and some of the mountain states. And as you go east and north, there's less solar available. So generally, the same system located in Phoenix is going to generate a lot more solar power than the upper Midwest. And the point of showing these some of these variations is just to reinforce PV is a really key component of an off-grid design, but it's not It's not going to provide all the power on a daily or monthly or annual basis that the home will likely need. Other renewable energy sources we mentioned are wind and micro-hydro. Wind is viable in areas obviously that are going to get continuous or a lot of wind resources throughout the year. Coastal areas are a good bet. Some of the upper Midwest areas around the Great Lakes and the plains are also good. Typical residential wind turbines are horizontal axis with 2 or 3 blades. But just like PV, they're going to be intermittent. They'll produce at full capacity sometimes and far less at other times. Micro-Hydropower, just like you might imagine, it converts the kinetic energy of flowing water from a stream or a river to electrical energy. This is going to be limited, obviously, to sites that have access to those bodies of flowing water. We don't go into either of these topics a great deal in the course. We do, however, have some additional resources at the end if you want to dig a little bit more. So that's the electrical generation side with renewables. It's PV in many or most cases, or wind, or micro-hydro. In some cases, it might be a combination. And then we have the storage component. We're trying to reiterate we need some form of storage so we can store up that energy and use it when the house needs it. And one analogy is think of a barrel of water as our storage. So water going into that barrel would represent the output from the PV system, for example. The size of that barrel would be analogous to the size of a battery storage system. And then the rate at which we drain the barrel is the home's electrical use. And we want to balance all 3 of these things so that the system works well and we're not draining it too fast compared to the storage size or the energy going in. So in off-grid homes, the water barrel in our analogy is the battery pack. Flow out is the electric use of the home. Flow in is the generated electricity from the PV system, or when that's not adequate, from the backup generator. And we'll get to that in a minute. So as you might imagine, the sizing of an off-grid energy system has to balance several of these factors. So if we have a larger renewable system, that will mean more flow into the batteries, but larger renewable also translates to more PV, more cost. Another key thing to think about, which we'll talk about more, is the envelope. We don't want to just think about the PV, the generator, and the battery storage. Let's think about all the other loads in the home and how we can optimize them so we don't have to create an enormously large and expensive PV and solar system or storage system. So the building components, the envelope, and the electrical and lighting loads all come into play. The battery storage capacity determines the duration and the amount of power that's available before the generator comes on. And this 4th point is important to note, and we'll talk about this in the slides ahead, that some of the loads in a house, for instance, water heating, it's one of those thermal loads. If we can shift them away from electricity, that can take a pretty significant load off the system. We don't need the PV to generate that, all that electricity to heat water. We don't need the battery storage to store it. So that's a trend in a lot of off-grid designs to move some of the thermal loads away from electric and typically to propane to try to optimize the PV, the battery system along with the backup generator. And just a few quick words about the other, what's called the balance of system components and the backup generators. This equipment typically, these are the other components that are necessary to make all these components work together. And they typically include a charge controller, power conditioning equipment, safety equipment, and meters and instrumentation. And as we can see here from DOE website, the Energy Saver website, it notes that wind and PV standalone systems and batteries are needed to meet the needs during anticipated periods of cloudy weather or low wind. And to complement these, an inexpensive fossil fuel powered backup generator can also be used to cover unanticipated or occasional slumps in the resource. So this deals with the intermittent nature of wind and PV, that those resources aren't always going to be available to keep the battery charged enough to power the home. So the generator provides that backup safety net. When the renewables aren't adequate, the generator kicks in and can keep the battery charged enough to power the home. So generator technology has evolved to the point where it's not one size fits all. They're specially designed and warranted off-grid generators for off-grid applications. These units have special features that really line up well with an off-grid application. And on the other hand, using a standard backup power generator for an off-grid application probably won't be the best idea, and in many cases it'll void the warranty on the unit. One of the key features of off-grid generators is their ability to integrate the way they operate with the home's renewable and battery storage systems. An off-grid generator cycles on and recharges the batteries only when it's needed, when the batteries go below a certain threshold. So they keep the battery charged as they need to. But typically they will defer to the renewables first and allow them to charge the batteries. So an off-grid generator typically is not connected directly to power the home. Instead, it powers it's connected to an inverter charger, which sits between the generator, the battery bank, and the renewable energy source, typically PV, and the home. And so when the charge in the battery bank drops too low, below that threshold that we mentioned, the generator will cycle on and supply power through the inverter and recharge the bank. Off-grid generator models like the EcoGen that we showed in the prior slide can be set up so they automatically engage when the batteries hit a specific point, making sure that charging of the batteries is automatic and uninterrupted. And there's also controls that offer the option to limit how much the generator will actually recharge the battery system. So if the battery hits a threshold and the generator cycles on to recharge, it might not cycle up to a full charge, but instead hit some threshold at which it throttles back, and it allows the PV system the opportunity to recharge the battery system if it's able to do so. So that kind of a control setup would optimize how much the PV is used and reduce the fuel use on the generator. Off-grid generators tend to be, one of the significant investments in an off-grid home. So it makes sense to optimize how that system is used. And when the rest of the home is energy efficient, the home will use less energy. The battery will will go below its threshold less frequently. The generator duty cycle and run hours will be less. So sort of the main point is, it's not just the generator. The design of the home can also influence how the generator is used and its life cycle. A couple other key features to point out on this slide. Off-grid generators feature long duration between oil changes, around 500 hours. And that third point is really important too. They offer quiet operation compared to portable or standard backup generators, which makes a lot of sense because they're going to cycle on automatically at any given time of the day or night. So quiet operation is a good thing to have. Here's another project example. This is a home builder in Colorado, Stauffer and Sons Construction, that does a mixture of grid connected as well as off-grid homes. And they tend to be lodge style mountain homes at a pretty wide price range, from the 300s up to the 7 figures. And their buyers in these sort of lovely mountain settings typically are looking for some of the gas-based amenities for heating, cooking, and outdoor living. And as I said, many of the projects tend to end up off-grid, some by necessity and some by choice. And as this quote indicates, we may be building off-grid, but we're not building a cabin in the woods. They're building higher end. So we'll have built-in redundancy in the system. So a propane backup to a photovoltaic system is an absolute must. So this indicates their strategy to off-grid design. Often it's PV. They'll look for other renewable energy options in some cases, but typically end up using PV. And as this quote indicates, they're looking for some backup and redundancy, so we'll couple that with propane backup generation. And a couple last words about these generators and the way they can integrate with an off-grid layout. Typically, they'll use propane, and as you can see here, there's storage options for keeping that propane on an off-grid site. Depending on the size and the usage rate, there can be enough propane stored at a site for months, or in some cases 1 or 2 or even more years. It automatically fuels the generator. It's going to have less CO than gas-fueled engines. And even though many off-grid locations are quite remote, in the cases that we saw, they still have access to periodic propane refueling, so that's a viable option for them. And while diesel might be considered for backup generators, and it can be, propane has a couple advantages. One is the stability of storing the fuel. It doesn't have some of the storage issues that you'll find with diesel in fuel stability. And then secondly, propane is more versatile in that it can also power the space heating and the water heating, as we've alluded to. So it offers that flexibility to not just operate the generator as needed, but also to take some of those other thermal loads off the electrical budget for the home. Okay, so those are the sort of the key components of the energy backbone: the generation, the renewable generation, PV, wind, micro-hydro, battery storage, and then the backup generator to provide that safety net. But it's really important to note for off-grid designs, it's not just a matter of figuring out those 3 components and then you have a design. These other elements of the home are really important as well, because everything works as a system in an off-grid home. So we'll talk quickly over the next few minutes about envelope design, mechanical system, and appliance selection. So the overall goal for the building envelope design is to reduce the heating and cooling loads. And there's a couple ways to get at that. High levels of insulation and really good air sealing for the building envelope. Rethinking the home size, how much house is actually needed. Because unlike a grid connected home, an off-grid home really has to account for all the loads. And the bigger the home gets, those loads tend to increase, whether it's space heating, space cooling, or even some like the lighting and the plug loads. And then the use of natural features and site characteristics. Many off-grid homes are in remote locations. They might have access to steady winds, which can be used for natural ventilation. Some off-grid homes are built into the side of hillsides that take advantage of the thermal mass of the earth. Other solar or other homes utilize passive solar heating, so they get some free heating from the sun during the winter, but avoid getting overheated in the summer. So here's a few examples. We just mentioned passive solar design. Typically, those types of designs, they use overhangs, so the summer sunlight is shielded from coming in window area, so we don't get all that heating if it's not wanted. But the winter sun, as it's lower in the sky, can come in and offer some solar heating to the space, so it reduces the heating load that we need to meet with some other energy source. And then over on the right side, there's a number of projects out there under the name Earthship. This is the Brighton Earthship in the UK, which features quite a few components. You can see the solar cells on the roof, there's rainwater collection, a windmill, and here you can see that it's built into the side of the hill there, using the Earth's thermal mass to help moderate temperatures and reduce some of the heating and cooling loads for the space. When it comes to mechanical systems and appliances, the overall goal here is to reduce the electric budget for the home's mechanical and appliances in order to keep the size and cost of renewables and storage reasonable. So we've talked about this strategy a little bit already, shifting some of the thermal loads from electric to propane. Where we are using electric, really focusing on high efficiency systems. So on this theme of utilizing propane for the thermal loads, this quote is actually from a solar design firm in Hawaii, and they're mentioning that propane is the best way for hot water heating in a solar home, as well as the clothes dryers and cooking ranges. And again, the theory here is to remove some of the load on the electrical system, the solar system, for these applications that need a lot of heat, and instead use propane. Another one of these appliances, which is sort of in the middle ground, it could use electric, it could use propane, is the clothes drying. And granted, some off-grid homes may not use any clothes drying or may use it very sparingly. Other homes will have this appliance, depending on sort of the size, the style of the project. Outdoor clothes drying can be preferred from an energy standpoint, but it's not always possible. Could be cold, could be rainy. If a dryer is used, going with a propane system can remove the large electrical heating component off the electric side of the off-grid home. And generally, it's hard to say in all cases, but in general, off-grid homeowners are going to be pretty energy conscious. And if a clothes dryer is used and is fueled by propane, even then, the system will be used only for full loads, and it's probably used quite judiciously, so that limits fuel use. And then this last bullet is also notable that it's not just the dryer. A high-efficiency washer can do a really good job getting moisture out, so the clothes dryer just has less work to do to begin with, and therefore would be using less energy. This slide shows a couple examples of specific off-grid appliances. The top one is a wall heater. The bottom one is an oven range combo. These are propane-fired or fueled units, and they use little or no electric consumption. And that's important, again, because we don't want to have high electrical loads. Off-grid designs also want to avoid even systems and appliances that are drawing a low electrical load continuously if we can avoid that. Some of the features you'll find in off-grid appliances like this, they'll have a push-button spark ignition instead of any kind of electric ignition. They should use little or no electricity. The wall heater that you see there, units of this type may have small, really high efficient electric fans or no fans at all, and rely on convection to allow the heat to move around the room. A heater like this will heat a certain space or a room or a zone of the house. There might be multiple units of this type installed in the house, which can also limit fuel use because the residents can just keep warm the areas of the home that they're using at a given point in the day. And systems like the range that we see here are available in a variety of sizes that are available out there. And a quick word about the range. Some of the industry literature does note that ranges of this type can have what's called a glow bar, which is an electrical heating element even in a propane stove, which fires on or cycles on and off to keep temperatures more even. That can be a pretty heavy electrical hit in an off-grid design. So just a sort of a word of note there to be sure if a range has that kind of element, and plan for it accordingly if it is there. And generally, if there's a marginal cost to invest in an off-grid appliance like the wall heater or the range, generally that marginal cost is favorable compared to upsizing of the PV and the battery storage system. For some homeowners, CO2 emissions are a really big consideration for their off-grid design. And in ideal terms, an off-grid home would use 100% renewable energy. It would get all the energy it needs for the home from PV or from wind or some combination. When you look at the projects that are out there, that's pretty rare to find. Again, those thermal loads typically can't be handled entirely with PV and battery storage. So some of those loads end up shifting to an alternate source like propane. However, in general, these off-grid homes, which use both energy sources, will generally have lower CO2 emissions compared to the same home in an all-electric configuration connected to the grid. And the reason for that is, on average, on a national basis, grid-supplied electricity still has some significant CO2 emissions because a lot of that energy is generated from natural gas or coal and sources of that type. It will depend on the state, though, and in some states which are moving to cleaner and cleaner electric grids, the emissions from grid-sourced energy will be less. So it depends a little bit on the location. And then another factor to consider is that most off-grid homeowners, it's hard to say with a broad brush at all, but many or most will be very energy conscientious in how they use electric, how they use propane. And so that too helps improve the CO2 emissions profile of an off-grid home. So we talked about water heating a little bit as one of those thermal loads. Here are some of the options to get it off the electric budget for an off-grid home. Tank storage water heaters are out there. Tankless units, by their very name, they don't have a tank, they're not storing water, they don't have those standby losses. There are a few models out there with no electric consumption in the tankless category. It takes a little digging to find them, but there have been models available that don't consume any electricity, which again is ideal for an off-grid type of application. Boilers can also be used, and many of these systems will heat both the space as well as domestic hot water. These systems tend to get a little more complicated in their design. And it's also important to understand if a boiler has controls that consume electricity and how much the water circulators in a hydronic system will circulate, how much electric they'll consume, because again, those have to be accounted for in some of the sizing for the home's electrical systems. So it's sort of a trade-off. Boilers can offer some nice performance, that integrated system. Some projects prefer to go with a simpler standalone water heater, standalone space heaters like the wall heater that we saw a few slides ago. Moving right along, we'll shift gears. When we're using electrical components, it makes a lot of sense to tap into the big toolkit there is for high efficiency electrical systems. So we'll start with lighting. We've all seen LED lighting enter the marketplace. It's now cost competitive with incandescents and CFLs. You have some of these really impressive savings numbers like Energy Star rated LEDs save 75% in energy costs and last 25 times longer than incandescent. Increasingly, the variety of sizes and styles of LEDs is growing. And when you add up all the lighting in an off-grid home using LEDs, it's incredible how low it can be. It can be 100 watts, maybe 150. So an entire house for lighting is using the energy that used to go into 1 or 2 bulbs when we had incandescents. And a quick example that shows the cost effectiveness of LED lighting. Here we see an example home that could either use 60 watt equivalent LEDs or 60 watt incandescents. And we assume that there's a price premium for the LEDs of $350 per unit. It's probably far too high at this point, but we'll use that for the example. And the house has 12 bulbs, whether they be LED or incandescent. So there's a little bit of added cost to go all LED. It's not a lot of money, $42. And we shave from that $42, we shave off 624 watts of lighting energy if all the lights in the home are on. So it works out to reducing wattage at a cost of 7 cents per watt, which is really, really cost effective. If you consider that adding more PV costs about $3 per watt. So we can only trim so much energy with lighting because we only use so much energy for lighting, but it does make a lot of sense to use LEDs for the lighting, and we can see that from this cost effectiveness. As we look at cooling, maybe not all off-grid homes have cooling. Some will rely to a large extent on natural ventilation and sort of use natural cooling as much as possible. But when mechanical cooling is used, there's high efficiency AC systems that would make a lot of sense. And this is another example where getting the envelope really well insulated and air sealed is going to help. it'll reduce the cooling load, and we can have a smaller system which will run less. Ventilation tends to be pretty critical in off-grid homes, especially if they're newer and really well air sealed, which makes sense from an energy standpoint, but we want to have reliable, consistent fresh air in the home. So the second bullet down there notes HRVs and ERVs exchange the heat between the outgoing stale air, which is getting blown out of the building, and that's run through a heat exchanger, and it adds, it tempers the incoming fresh air, whether it's hot summer air, cold winter air. It's going to temper that air coming into the home. So we have fresh air, but it's not icy cold or really, really hot. And ERVs also exchange moisture, so it can wring out some of the moisture in the summer, maybe add a little bit of moisture when we introduce dry wintertime air. So those systems make a lot of sense in really well air-sealed off-grid homes. And there are indeed HRVs and ERVs which feature really high efficiency, low wattage fans, which makes sense for an off-grid application. Dishwashers, if they are used, should be energy efficient. Energy Star models are widely available. And dishwashers are another area where homeowner behavior, and typically off-grid homeowners will be cognizant of that. And they're not going to run a half a load. They'll wait until they have a full load and use the appliance judiciously. Closed washers, same kind of thing. We can go for high efficiency models that have high speed spin cycles, get more moisture out. We can compare Energy Star labels to try to identify the most energy efficient models out there. And then lastly, we call out that there are some direct current options out there. And this is a pretty interesting area of off-grid home design because the renewable energy systems, the battery systems in off-grid home, they're going to operate off direct current rather than alternating current. And to be in sync with them, off-grid homes have the option of utilizing specialized DC models of some appliances like lighting, pumps, refrigerators, and some other always-on components. So using DC appliances of that type avoids efficiency losses which happen when we convert electricity from DC to AC in an inverter. There are trade-offs involving energy savings, equipment cost, installation, and how appliances will interact with the home's inverter. So they go a little deeper than the detail that we're going to cover in this course, but we do cite some additional resources about DC current options in off-grid designs that we'll see here at the end of the course. Refrigerators, another big electrical load. High efficiency electric fridges are out there that may use less than 1 kilowatt hour per day. Super efficient electrical models can use half that model or half that amount, and they're found in both AC or DC models. Propane refrigerators are another option. These will often be used in homes with less PV generation, where they're really trying to reduce the electrical loads on the electric side, so they go with the propane refrigerator instead. Okay, so last but not least, we've talked about the energy systems, and we've talked about the building envelope design, the mechanical systems, the appliances, but then a lot of the outcome of an off-grid design comes down to the homeowner. As you can imagine, homeowners have a lot of impact on how an off-grid home will perform, how much energy it uses, how often it taps out the batteries, and the renewable generation just isn't enough, so the generator has to run more often, things like that. And I've mentioned a couple of times, off-grid homeowners are generally going to be fairly cognizant and aware of how they're using the home, probably more so than somebody in a grid-connected house, but there's a learning curve. And some of the examples of the considerations that off-grid homeowners need to think about are listed here. What are the set points for heating and cooling? And that has a direct effect on energy use. Optimizing the use of appliances. We talked a little bit about the use of a dishwasher, the use of clothes washers. Maybe adapting how they're using energy during prolonged periods of cloudy weather. If the home really relies on PV, and they're trying to get the most out of that PV and use the generator as little as possible, they might modify what they're doing when they have a lot of cloudy weather. Thinking twice about using energy-hungry electric appliances like a hairdryer. Performing battery maintenance. It's more of an issue with lead acid batteries as compared to lithium ion, and that's another trade-off that homeowners need to be aware of in the system design phase. Cleaning off PV panels. As you can see in this picture, wintertime is tough enough with fewer hours of daylight. If we get snow cover on the PV array, and the output's really going to fall off, obviously. Actively measuring loads. And a lot of homeowners don't realize that a particular appliance might be continuously drawing some amount of wattage, and over 24/7, 365, that adds up. And then the last bullet refers to system monitoring, looking at the big systems. Is the PV system generating as expected? Understanding how much it typically puts out over a summer day versus a winter day. Looking at the battery level, looking at the generator runtime hours and making sure that's maintained and running properly. So all those things go into an off-grid home's behavior and how it operates. In grid-connected houses, homeowners may do a few of these things, but it's not quite as pressing as the off-grid scenario. Just a couple slides here to wrap up. Cost is always part of a project design, and off-grid homes are no exception. So it's worth noting that there probably are incentives for off-grid technologies. These could apply to the renewable energy systems like PV, or they could apply to high-efficiency building technologies like a tankless water heater. And we say probably because these things are a shifting landscape. They come from federal sources, state sources, or maybe industry groups like state propane gas associations. But the terms of credits and rebates continually shift. The applicability might change. But generally, there are some opportunities out there, and it's worth doing a little bit of research to figure out what incentives might be available. So we know two good websites for doing that research. The first one, dsireusa.org. Is a national database. It's pretty well maintained and it's searchable, so that's a good resource to look for incentives and rebates of all types. And then propane.com, if you want to search under incentives, that will kick out state level incentives that could apply to things like a tankless water heater. So I mentioned these additional resources a few times, and by no means is this a comprehensive list. There's a lot of material out there about off-grid home design. These are a few that sort of stood out as we were putting this course together. The first one is an online video highlighting different appliances that are used in a cold climate off-grid home design that was being built. The next one is background information and system planning insights for micro-hydropower systems. The next two are those websites that we just mentioned a minute ago that are good places to do some digging on potential rebates or incentives. The next item down there is background and planning guidance for small wind electric systems that might be a consideration for an off-grid project. And then lastly is an article discussing when to use DC appliances, some of the pros and cons and things to think about. And we do want to note that these resources and their links may change over time, and their listing here is not an endorsement, but an FYI that they're out there, and you can certainly find more information on off-grid home design. So with that, I'll pause, take a breath, get a sip of water, and we can see what questions might be in the queue. And also know we listed two websites there, as well as contact information for Brian Cordell with PERC, who heads up the residential and commercial programs.
Sure, thank you, Jamie. We did receive one question, which was a little bit earlier, and the question was, how does Scotty's Castle in Death Valley give us some insight? From J. Randall Thompson.
Please repeat the question. I'm not sure I'm going to be able to answer it accurately, but could you read that back again?
definitely. The question shows here, how does Scotty's Castle in Death Valley give us some insight? Now, Jay, if you're still live in the call, please, if you had any other additional information on that question, I can read it out to you, or we can even round back via email as well.
Well, I'll throw out a response there. I'm not familiar enough about that particular building or project to comment what we might learn from it, but it does raise the issue of learning from the projects that are out there and understanding what are the best ways now. You know, if you were going to start an off-grid home design today for a given climate, what would the optimal design look like? You know, how much PV, how much battery storage, or is it better to invest a little bit less there and a little bit more in the building envelope or the mechanical systems? And that's sort of a moving target, and it's not the same everywhere, especially as prices fluctuate and things like PV get cheaper. But there does seem to be a lot of industry dialogue where practitioners in the off-grid space trade notes and share their lessons learned about the ideal approaches for off-grid designs.
Got it. Thank you, Jamie. Now, if any of the attendees have any questions, please do throw them into the questions chat area of the GoToWebinar. As of right now, Jamie, though, that was the only question we've received so far.
Okay. Well, thanks, Preet. I would suggest wrapping it up. I know everybody has a busy schedule. If there are additional comments that come to any of the attendees after the fact, they can reach out to Brian Cordale, who's listed here, and he can direct the questions or respond, whatever makes the most sense.
Sounds great. All attendees, thank you for your time today, for joining the call here. Happy holidays to all, and I hope everyone has a great day.